Welcome to Lesson 2.3 Privacy Engineering and Differential Privacy. So, by the end of this lesson, you'll understand privacy by design principles in AI systems, explain key privacy engineering techniques, explore synthetic data generation and validation for privacy preservation, and evaluate trade offs between data utility and privacy. So, let's begin. The role of privacy engineering. Privacy engineering transforms compliance into design. Rather than retrofitting controls after incidents, privacy by design integrates them throughout the AI lifecycle, from data collection to model deployment. It ensures systems are resilient against unauthorized access and data misuse. Regulatory frameworks like the GDPR and the upcoming EU AI Act demand demonstrable privacy practices. By embedding these principles early, organizations don't just protect users, they establish trust and long term credibility for their AI driven products and services. Privacy by design principles. The privacy by design philosophy encourages foresight. It's about building privacy into every layer of technology and process. Data minimization ensures only essential information is collected. Purpose limitation ensures it's used solely for intended goals. Systems must also maintain end to end security, from encryption at rest to access control in use. Finally, transparency and user choice are paramount. Individuals should know what's happening to their data and be empowered to consent or withdraw, reinforcing ethical stewardship in AI innovation. Key privacy techniques. Differential privacy. Differential privacy, or DP, mathematically guarantees that the removal or inclusion of a single individual's data doesn't significantly affect analytical outcomes. By injecting calibrated randomness or noise into data or model outputs, DP obscures individual contributions while preserving overall trends. Tech giants like Google and Apple deploy DP in telemetry and analytics, allowing learning from vast user data without exposing personal details. It's a cornerstone for privacy preserving AI, especially in federated or distributed learning environments where sensitive data cannot leave local devices. The strength of DP lies in balancing privacy risk and analytic precision. K-Anonymity and L diversity. K-Anonymity ensures that each individual in a dataset shares attributes with at least K-1 others, making it difficult to link any record to a person. However, if all K individuals share the same sensitive trait, like diagnosis or salary, it still risks exposure. That's where L diversity comes in. It requires diversity within those sensitive values to reduce predictability. These techniques are foundational in data anonymization, especially for health and finance datasets, where structured tables are common. They form part of a broader privacy toolkit that evolves to counter re identification attacks in modern data analytics. Synthetic data generation and validation. Synthetic data replicates the patterns and relationships of real data sets without containing actual personal records. Generated using statistical models or generative AI, it provides safe alternatives for testing, research, or model training. However, Quality assurance is essential. Poorly generated synthetic data may fail to reflect real-world variance or introduce bias. Validation checks such as validation checks such as distribution matching, outlier detection, and bias testing ensures utility and fairness. When done correctly, synthetic data allows teams to innovate faster, collaborate securely, and uphold privacy commitments across AI pipelines. Balancing utility versus privacy. The central tension in privacy engineering is balancing utility with protection. Strong privacy controls, like high noise levels and differential privacy, can degrade data utility, while high accuracy may compromise anonymity. Mature AI programs adopt risk based frameworks, assessing context, purpose, and sensitivity to find the right trade off. Techniques like adjustable privacy budgets and dynamic policies allow adaptive protection over time. This balance is never static. As threats evolve or datasets grow, organizations must continuously recalibrate privacy thresholds to sustain both model performance and ethical responsibility. And now for the key takeaways. Privacy by design embeds ethics and compliance into AI systems. Differential privacy, k-Anonymity, and L-diversity form the technical core. Synthetic data offers safe innovation when validated properly. True excellence lies in balancing insight with individual protection.